Yeah, okay, nice.
Dear testers, welcome to the 6th edition of TestCon Europe. I am Jonas, and it is my pleasure to be a host of such a high-level conference that focuses on software testing. I am myself currently the managing director of AskUI, a company which humanizes test automation. Furthermore, I'm the organizer of the software testing meetup Karlsruhe. So I think it's no secret that I'm quite into testing. I believe this conference is so relevant because of the fast transformation of software development processes. We have ongoing trends in automation and are changing environments so fast that testing is adapting. TestCon Europe is the place to be when it comes to these developments. Furthermore, I just love the testing community. What can I say more? Today, we are live streaming to more than 17 different countries. Thank you all so much for joining. We are not meeting on-site as usual. However, we expect the 2021 online edition to be just as good as it was before. For this purpose, we are using this advanced event platform, which allows us to live stream sessions, engage with each other through live chat, check schedule, get to know all the speakers as well as attendees at this conference. What is more, you can visit our sponsors at their virtual booth and of course get help through the help desk if you got lost in this colorful environment. All of the virtual event platform possibilities you can explore during the breaks. We will also have a special slide for you explaining the different platform functions. This year, each track will be moderated by different and well-known testing experts who will do their best to make your conference experience as enjoyable as possible. Moving forward, this year we also have great sponsors who I'm very grateful to introduce to you. One of them is Accenture. And this is what they say about themselves. Accenture is a leading global professional services company, providing a broad range of services and solutions in strategy, consulting, digital, technology, and operations. Combining unmatched experience and specialized skills across more than 40 industries and all business functions, underpinned by the world's largest delivery network. Accenture works at the intersection of business and technology to help clients improve their performance and create sustainable value for their stakeholders. Another sponsor is MetaSite. At MetaSite, they do bespoke digital financial platforms and applications design, engineering, integration, and support for financial industry leaders and rising fintechs across Europe. The company consists of technology professionals who believe in the power of a dynamic, flat hierarchy culture, constantly explore the latest IT trends and tools, and enjoy working in autonomous teams. Their financial systems architects, software developers, UI designers, QA engineers, analysts, and product managers offer a rare combination of deep understanding of the financial services domain and bespoke software engineering excellence. We also have a knowledge sponsor, PACT, who will award the most active big data conference attendees with an ebook of their choice. Participate actively during the conference, rate the sessions, and win a book from PACT. After the conference, the most active attendees will be selected and be given a chance to choose an ebook from the wide range of PACT books. So take an action and win. Our last sponsor is Wix Engineering. Wix Engineering develops some of the most innovative cloud-based web applications that influence more than 160 million users worldwide. What is more, make sure you check the schedule and join your favorite sessions or panel discussions. Almost last thing for me, I would like to also encourage you to be as interactive as possible during the conference. Focus and enjoy. The lineup this year is so amazing. I bet you know that already. That's it from me for now, my dear friends. And now I would like to introduce to you our opening keynote, Phil Royston. Phil started his career in software testing in 2002 and is since then a software testing enthusiast. He furthermore co-founded Tesena in 2013, a software testing service provider based in Prague. Currently, he holds the position of the CEO in his company. Hey Phil, how are you today?
I'm good. Excited, nervous, but I'm good.
Sounds good. I also read that you had a rather unexpected career switch in software testing.
Yes. I got into software. It wasn't intentional to get into software testing, I have to say. Yeah, I have a little bit about it in my slides, so I don't want to say too much. But I think when I talk to many people in software testing, it's the same. Many people get into software testing, let's say by accident. but then stay there because they love it. So that's my story too. I love software testing.
Well, then I'm quite excited to hear more about later. And also the first time I read your keynote description, I really was wondering how testing is like electricity. And I'm really excited to figure it out right now. So without further ado, I will hand over the word to you, Phil.
Thank
and
you.
Everyone enjoy the session.
Okay, I shall share my screen. And hopefully you can now see my presentation. I shall get rid of that. Okay, so let's go. My name's Phil. Welcome to TestCon 2021. I spoke at the conference last year. I had a lot of fun. It was a great conference. There were some really super speakers. It was really well organized, and I was absolutely delighted to be asked back to give a keynote this year. And the keynote is asking the question, is testing like electricity? Now, my job as the opening keynote is to charge you up, so to speak, or fill you with energy. And there's my second joke, and get you ready for the rest of the conference. And joking aside, I really hope I can kick off the conference and give you something to take away that will motivate you to become a better software tester. So, first of all, I need to give a warning. This presentation does contain time travel. If you're like me and you're confused by films and stories that contain time travel, then please, you have to pay special attention, or else you'll just get lost at some point in the presentation. If you find time travel disturbing, then you may need to look away from the screen from time to time. Now, if you found the previous slide weird, then just be aware that I was trying to be funny. And at any point in the presentation where you think I'm getting a little bit weird, then just be assured that I am actually trying to be funny. And who am I, apart from being a failed comedian? Well, I'm a CEO. And you may be wondering what a CEO could tell you about software testing. CEOs are these guys, you know, they're visionary, they're building these disruptive digital businesses, they're building spaceships to escape the planet that their resource-intensive businesses actually are helping to destroy. Well, I'm not that sort of CEO. And the second point is that I'm the CEO, as we mentioned, of a software testing company called TestCon. Why did I found a software testing company? Well, the reason was that before that, I was angry. Specifically, I was an angry test manager. And why was I an angry test manager? Well, before that, I was a wise test manager. And why was I a wise test manager? Well, before that, I was just some generic IT guy. Now, you may have noticed that we've traveled backwards in time, and we've actually traveled backwards in time about 20 years. Let me roll the time machine back into forward gear, and we'll go forwards in time again. So I was this generic IT guy. I was asked to take over the test manager role on a project. I said, okay, I like a challenge, fine. I knew nothing about software testing. And therefore I was in this project and I kept coming up against software testing problems. And I invented solutions. And these solutions seemed to work, and people seemed to be happy with the result. And they started saying, Phil, you're a good test manager. And I believed them. And then after a few years, I said, okay, I should get a certification. I should have a certificate on my CV to prove that I am a wise and great test manager. And I did ISTQB foundation level. Now, whatever your opinion about ISTQB is, it's a body of knowledge. There's some collected learning there. And I found out while doing the ISTQB foundation level that the problems I'd already found had been found many, many years before. And people had invented solutions for these problems, which are actually a lot better than my solutions. And that made me really angry because I realized I was nothing more than a competent amateur. And I looked around and I realized a lot of other people in software testing were just like me. They were amateurs, competent, incompetent, but they're amateurs. And then, worst of all, I realized that people looked at us testers as, you know, yeah, they're nice guys, but they're not really professional like us. And that made me really, really angry because reading this body of knowledge from the ISTQB, I realized that testing was a profession. And in order to change the testing world, I founded a software testing company called TestCon, and therefore the story goes on. And really that comes down to my life motto. That experience taught me that there's a lot of good stuff, a lot of good ideas already out there, and we really should start using them. So, is testing like electricity? Now, if you've read the abstract, you know already that this presentation title was given to me by people with a cruel sense of humor. And this could be the shortest keynote presentation of all time, but I like a challenge, so I thought I'd have a go. And so let's look at it. This is a definition of electricity. Energy, charged particles, blah, blah, blah. And here's a definition of software testing. Fulfills expectations, we detecting defects, blah, blah, blah. Are they the same thing? No. Okay, so let me think about this from a different point of view. So I said, okay, I'll test myself to compare the electricity business with the testing business. I'm a testing businessman, something I apparently should know something about. So I'll compare my business with the electricity business. So let's just give a quick overview of what the electricity business is. All businesses have to meet a demand. If you start a business that has no demand, your business will fail. You'll go bankrupt very quickly. So there has to be a demand. So here we have some consumption of electricity. And if you have a demand, then you have to solve the supply. The electricity business solves that with power generation. And the bit that's maybe not so obvious in the electricity business is that in between the power station, which is built a long, long way away from where you consume the electricity, there you have to actually get the electricity from the generator to the consumer, and therefore they have distribution. So if I try to compare this electricity business with the testing business, we generate tests and there's some consumption of tests, but it's not really keynote material. So let me take another step back, and I'm jumping in my time machine and I'm going back to the beginning of the electricity business. And the beginning of the electricity business started with the light bulb. Now, why the light bulb? Well, the light bulb was a demand, yeah? And why was it demanded? It's because otherwise it was dark. And if it was dark, then there was a risk. There was a risk that in the dark, while you're walking down the street, you would fall over something, that you would walk into a building, that you would be hit by a horse. And these are actually were common events that occurred while walking along Victorian streets. And so there was an identified risk. People wanted some stable, reliable, long-lasting, clean, bright light. So many people were trying to solve this problem. They realized there was demand and they thought they'd have to invent a light bulb that fulfilled that demand. And two gentlemen you probably heard about, pretty much in parallel, came up with a solution, Mr. Edison and Mr. Swan, because you might be confused where we are in time now, 1879. And who was there first? It depends whether you're an American or British. If you're not either of those, you probably don't care who invented the light bulb first. So they invented the light bulb and mitigated the risk. And they weren't the only two people in the picture. There was Mr. Morgan. Mr. Morgan of the investment bank was actually investing money, I think, into Mr. Edison's research because he saw here a potential for a money-making machine. Okay, so there's the birth of the testing industry. Electricity industry. So we have consumption, electric street lights, and then that was just the start of the story, because then they had to solve generation. So there's a lot of innovation had to be done in generation, and they had to do a lot of innovation in distribution. But that's the birth of the electricity industry. Now, testing industry, start of the testing industry. In my 5 minutes of Google searching, I couldn't find any reference or anybody that was saying this is where the testing industry was born. So let me take my time machine and I'll zoom right out. I'm going to look at a few hundred years of time here. And when I take that point of view, I can see 4 industrial revolutions. We're currently in the 4th one. The first one was driven by steam power. The second one was driven by electricity. Mr. Swan and Mr. Edison created a demand or fulfilled the demand by creating the electric light bulb, and then they had to solve generation. When electricity was being generated, more people started demanding electricity for different uses, production lines, mass production. And that started off the second industrial revolution. The third industrial revolution is driven by silicon, because we're in the 4th, silicon microprocessors, computers, or even more simply, IT. Okay, testing is part of the IT business. So let me just concentrate on the start of the IT business. And here it says 1969. This is because in 1969, something called the PLC, Programmable Logic Controller, was invented, and this enabled automated production lines. But these dates are not so specific, and I'm actually looking, I think, at 1964. So I'm jumping in my time machine and I'm going to 1964. What happened in 1964? Well, interestingly, it was the Tokyo Olympics. The Beatles released their third album, A Hard Day's Night. Good one. The Rolling Stones released their first album, interestingly called The Rolling Stones. Martin Luther King received the Nobel Peace Prize. Ford released the Ford Mustang, classic car. Mary Poppins was released, really timeless and classic film. And finally, some men in hats and long coats were boarding a train at New York Central Station to go to IBM's headquarters. Why were they going there? Well, they were going there to listen to an announcement by this guy. Meet Mr. Watson Jr. And he was making an announcement about the thing he's leaning on. So what was all that about? Well, jumping back in my time machine, just going back into the 50s, let me explain the situation. In the 1950s, there were computers for science, there were computers for business. IBM itself had 4 computer business lines. Yeah, they had 2 business lines for business computers, so a small business computer, a big business computer, and they had 2 business lines for science computers, a small one and a big one again. And in those days, if you wanted to upgrade, well, you couldn't. Basically, you just had to buy. If you were running a computer and your requirements had outgrown its capacity or its capability, then basically you had to go out and buy a new one. And when you bought a new one, you had to rewrite all your code. Imagine that, if you bought a new notebook and you had to rewrite all your code. So what happened was, first of all, something really strange started happening in IBM. And I read it as such that they were actually trying to solve their internal politics. They had these 4 big computer divisions, and the internal politics were so bad that they wouldn't talk to each other. They wouldn't cooperate on anything with each other because each one thought that their machine was the best one. And IBM tried to solve this internal politics by taking the head of one division and put him in charge of the other division. And that created some friction. And then really strange things started to happen. And after a number of years, they came out with this thing. And it was a huge task. And the IBM really at the end were betting the whole company on the success of this one machine, the IBM System 360. Now on this picture, you can already see the 1960s chic. I like that. And it's a beautiful machine. I'm old timer. Anyway, so what was the IBM 360? Well, first of all, you could use it for science and you could use it for business. Nice, universal machine. The other interesting thing about it was upgradable. You could actually buy the lowest range model, and without rewriting any code, you could quite simply upgrade to a higher powered machine. Amazing. And the third thing about it that was actually amazing was it was compatible. You could plug in peripherals from other companies. So if you had a punch card reader or a reel-to-reel tape drive reader or a system printer from another company, you could just plug it into IBM 360 and it would work. It was compatible. Now, this was such an amazing money-making machine. At the time of its announcement, there were 20,000 mainframe installations worldwide. 20,000. Within 1 month of releasing or announcing the IBM System 360, IBM got orders for 100,000. 100,000 in a month. In 5 years, IBM doubled in size. It was already huge, but it doubled in size. And it almost tripled its revenues. And it wasn't that IBM created a killer product that wiped out all the competition. All the competition had benefited too. This really was the machine that started the IT industry. Business started buying machines a lot because it was a future-proof machine with upgradability and compatibility. Wow, an amazing project. And for me, amazing product. And for me, that's the start of the IT industry as we know it. Another amazing thing about the IBM System 360 is it could do this. NASA used it to as a navigational computer for its Apollo missions. Wow, yeah. So if you're on an Apollo mission and you've got and I believe this to be the ultimate user story, put a man on the moon, and I love the second part, and bring him safely back to Earth in a decade, so it was quite smart, then you've got a risk. And the risk is you'll get lost in space, because the maths of spatial navigation, navigation in space, is so complicated. That's the reason why NASA, spent a lot of time developing software and using those mainframes and onboard systems to actually prevent those astronauts getting lost in space so they could safely return to Earth. Now, if you read NASA's history of computers in spaceflight, is on the internet. It's actually very interesting reading. Lots of technical things which I don't understand. But in there, they actually openly and transparently say they had huge problems with software quality. Their systems weren't working. And they deal in that story in how they tried to resolve those problems. And they start talking about different test levels: unit testing, end-to-end testing, integration testing. And they also start talking about independent verification. They had a programmer and they had a second programmer. They didn't call him a tester, but he was a second programmer, and his job was to write test plans and test cases to make sure that the software that the first programmer was writing actually did what it should do. I would like to believe that that's also the start of the software testing industry. Our testing industry started with the NASA missions, and that would be a fantastic thing. So, my first test, electricity business, the same as a testing business? Well, they have the same why, risk mitigation. So, I believe I passed the test. Okay, not satisfied with that. I do like a challenge, so I've set myself up a test set. I've got 5 tests. The first one I've already passed. The next tests are: electricity makes modern life possible, electricity is dangerous, electricity demand is unpredictable, and electricity could help avoid a global crisis. So, wish me luck. Here we go. Electricity makes modern life possible. Well, compared to the previous test, this is really, really easy. Here's a photograph with 2 mobile telephones. To avoid anyone feeling excluded, I've included an Apple-based device and an Android-based device. They look pretty identical, but maybe you can tell the difference. So, as we know, mobile phones are an integral part of our modern lifestyle. So, both mobile phones run on electricity. So, electricity makes modern life possible. They also run on software, and software is tested. So, testing makes modern life possible. Actually, there are actually more software platforms, in my opinion. They've got mobile apps and web apps in the browser. They're the things that we're using on the mobile phone, navigation, online shopping, and so forth. They're part of our modern lifestyle. So, but it's not just those sorts of things. It's even quite mundane things. If you imagine warm beer and dirty clothes and student food, then these days we've got smart devices, fridges, washing machines, microwaves, cookers, have all got embedded software. Sometimes they're also connected to the internet, so it's IoT. And these things are looking after keeping the beer cool, keeping your clothes clean, and making your student food palatable. So my point is, where we have software that meets the demand, then I'd like to think that somewhere in there is involved a software test. And that software tester obviously did a good job because he made sure that the software met my expectations and my requirements. So, go tester. My third test, testing is electricity. I don't have any slides to explain why electricity is dangerous. If you're not sure or you're unaware that that electricity is dangerous, then please perhaps contact me after the presentation and I can give you some safety tips. Testing is dangerous. Why is testing dangerous? Because we write killer tests. We write tests that bring down features. We write tests that bring down applications. We write tests that can bring down organizations. we can bring governments and civilizations to their knees. So joking aside, is testing dangerous? Well, it's challenging. I'm sure all of you faced at some point some very, very challenging situations in our profession, but it's not dangerous. Fortunately, it's not dangerous. But let's just look at what we're doing. Somebody makes a mistake. That causes a defect in the system, and there's a risk of failure. And that's the danger. The failure could create some sort of danger. And when we talk about safety critical systems, it's clear. If you're in an operating theatre and you're hooked up to a piece of software that is monitoring your blood pressure, your oxygen level in your blood, it's measuring your heartbeat, and it's measuring whether your nervous system is still sending electric signals, and that machine hung 20 minutes ago and the surgeons are unaware of it, then that's obviously a very dangerous situation. And as we saw recently with the Boeing 737 MAX, software sometimes goes wrong, and with fatal consequences, unfortunately. But it's not just that. Many businesses today are completely dependent on software. Digital businesses are completely dependent on software. And if the software is bad, then that could impact profits. And it could also impact your reputation, because we're all fighting for stars on the App Store or on the Play Store. And it's not just business, it's life. How we work, how we relax, how we talk to each other is these days dependent on software. So if it's bad software, then that could really impact the way we live. And if it's wrong, if the software is bad, where do we go wrong? Is it bad requirements, bad design, bad coding, bad planning? And a few years ago, we used to be on software testing conferences talking about bad agility a lot. Is it any of those things? And I think this is our testing blind spot, because our job is to find other people's mistakes. That's what we're doing. And it's easy just to be focused on those things and not actually do the self-reflection and think, did we make a mistake? Is it because we did bad testing? And we have to understand that testing is an integral part of the software delivery cycle. In waterfall days, it was at the end. And that was quite nice sometimes, because software testing really, really did sometimes save the project. We were the heroes again. But in these, fortunately, modern iterative days, where we're focusing more on collaboration and it's more on cross-functional approach, and I'm really, really happy we've moved in that direction, testing is still an integral part of what we're doing. So, as I said, why we're here, humans make mistakes. Software delivery is done by humans, and our job is to mitigate the risks and impacts of those mistakes. So bad testing is dangerous. So that's fairly obvious, I think. I mean, you probably came to that, I hope you maybe have come to that conclusion yourself, but there's something else happening in software delivery these days, and it's being driven by digitalization. Now, in 1975, I'm back in my time machine. Digitalization was that instead of having fingers on your watch, you had digits, digitalization. In the mid-90s, it was because we stopped using chemicals or chemical processes to record images. We use electrical processes and storage to record images. And in 2021, jumping forward, digitalization means almost anything you can think of. In fact, it's one of the most overused words. And many people don't actually know what it means. I found a nice explanation from Gartner, a definition from Gartner, but my take on it is, in the old days, non-IT people were responsible for generating revenues. They were in contact with the customers, and they were delivering, creating and delivering the product and services to the customers, and the IT guys supported them. Digitalization means that the IT guys are responsible for generating revenues. They're in direct contact with the customers, and they're generating and delivering the product, and the non-IT people are supporting us. So it's a big switch. And what that means is that we should be fully focused on delivering business innovation and value. And what that means, we're at the forefront of competitiveness. Our business can be successful or fail based on how competitive our software delivery is. And that means speed. If you've got a good idea, you've got to get it out fast. One of your competitors could be there first with a similar idea, and it's got to be in good quality. If you go out with something and it gets 1 star in the App Store, you've wasted your time. So how do we approach this problem? Well, we've switched or changed the way we're working. So we started playing with Agile. Yeah, so it's iterative. We may not release. We had 2 weekly sprints every 2 weeks. We may not have released at the end of 2 weeks, but we changed the way we worked, and now we've moved into DevOps, which I think is really, really exciting. And in DevOps, there's been the rise of these high-performance teams. These guys are releasing software every few hours, not every 2 weeks, not every 2 months, every few hours, and several times a day. High-performance teams. And this is the future of software delivery. And what do they think about software testing? Well, they're not too impressed. There was a few surveys out 2 or 3 years ago where they said the biggest problem for them, the biggest bottleneck, is testing, because it slows them down and it actually prevents them from achieving high quality. Actually, the things they're trying to achieve. So how do we answer that problem? Or what we're talking about is the answer to that problem is test automation. Good, but it's not the silver bullet. It won't solve all the problems. So I'm not an expert on test automation, so I'm going to talk about something else. One thing I've seen recently is, or become aware of recently, is setting the appropriate quality risk sensitivity. Yeah, because when I first started out as a test manager, we had a rule which said no severity A defects, maximum severity 5 severity B defects, and we thought we were really clever. And it was. So let me just take three quality characteristics. Yeah, and if you're setting your quality and risk sensitivity levels as follows, that the application can never crash. And you're testing it in a way that you're not just testing the positive scenarios, you're testing all the negative ones, and you're testing loads of edge cases. And anytime the application crashes, says, oh, that's terrible, we cannot go live. And if you're approaching the performance of the application that you expect 500,000 millisecond response time, and the system must, for 48 hours, without ever slowing down, needs to process millions of transactions. And if you approach security like, this system contains Elon Musk's Bitcoin password, then it's going to take a lot of testing to go live. But if in reality, all you're trying to achieve, or what you need to achieve, is that most of your users can use your application for what they mostly need it for, then it's a different style of testing, it's a different approach for testing. And if, nobody needs 0.5 millisecond response time, we're multitasking. It can't be irritatingly slow. It can't apparently hang. Yeah. So you need to have a reasonably good response time. And to security, yes, security is very, very important. But let's, set an industry standard target, not something at Fort Knox level. So if we adjust our sensitivity to more a realistic level, then we'll test less. And we'll also test smarter, because we'll be testing the stuff that's actually important, and not millions and millions of edge cases, or trying to achieve something that nobody really needs. And you will be faster. And if you've solved that problem, that you're testing smarter, then if you start automating, then you'll have a good basis for your automation tests. If you're not testing smart and you try to automate it, first of all, you're going to create yourself a hell of a lot of problems trying to automate. Yeah. So actually your job becomes a lot harder, and you're automating junk. It has no value. If the tests are not good in the first place, then don't automate them. So, test 4. Demand for electricity is unpredictable. And now I'm going to talk a little bit more about electricity, because this is quite interesting. So, when you plug in your mobile phone, it starts to charge. And that's actually a bit of a miracle, because if the grid that distributes electricity gets out of balance, it breaks down. So what goes out needs to go in, and what goes in needs to go out, or blackout. And of course, there's some automated processes there that can make micro adjustments. It's not like Bob and Harry down the generation plant say, hey, I think Phil's plugged his mobile phone in, let's turn it up a little bit. There's some automated processes there. But at the macro scale, it's actually quite difficult. This is a generation profile for the Czech Republic for Christmas Day, and it's the simplest example I could find. So you can see here how people's behavior impacts the electricity demand. As I say, they're generating electricity in response to demand. So if you look at, just ignore the colors for now, if you just look at the top line, it's Christmas Day. People sleep in, then they get up, they start making Christmas lunch. Yeah, so around lunchtime, the energy demand goes up. They have to generate more electricity. In the afternoon, they might go out for a walk. And in the evening, it's 4 o'clock. You need to switch the lights on. It's dark in Northern Europe. And towards the evening, people gravitate towards the TV. They start drinking cold beer. You need to keep your fridge running to generate cold beer. So the electricity consumption goes up. And then towards the evening, everybody goes to bed and looking forward to the next day. So that's a very simple profile. If you look at a winter working day, and I'll just flick backwards and forwards through the slide, you can see it's a completely different profile. And this is the problem for the electricity industry. They need to predict this profile because supplying electricity is actually not that simple. And if I go to here you've got some businesses which are coming online, so you can maybe predict that they'll need some electricity. So, okay. But here we've got a special event or a specific event. If you see the previous slide, everybody goes to bed, the power consumption drops off, and here it jumps up in the evening. And why was that? Well, the reason was a hockey match. The Czech Republic is crazy about hockey, and the Czech Republic was playing Russia in the World Hockey Championships, and the Czech Republic scored an early goal. When people heard about this, they rushed down the pub or rushed home and switched on the TV and started drinking cold beer, obviously consuming more electricity. So it could actually be a specific event, an unpredictable event that impacts on the demand for electricity. And if you look, and I'm going to talk about this for a little, it becomes more relevant later, but I'll talk about how they actually supplied. Now, these days, the drive is for green energy, wind, hydro, and so on. But for the electricity industry, that's a bit of a problem because in the old days, they had coal and they had gas. And coal and gas is perfect for them because it's super flexible. They can keep coal and gas power stations in some sort of hot backup. So when people start going to work in the morning and they need to generate a lot more electricity, they can bring those power stations really, really quickly online. They've got really no problem. It's a very flexible system. Now, when they start using alternative sources of energy, it becomes much more complicated. Now, the big yellow lump in the middle is nuclear power. So whatever your opinion about nuclear power, the Czech Republic has a huge capacity for nuclear power. And as you know from any disaster movie, nuclear energy is very, very difficult to switch off. In fact, you can't just switch off a block or switch on a block. So it's something that runs the whole time. So you have to set it up as your base load. That's the stuff that's there always. It doesn't actually change. If you actually look at the graph closely, you see the amount of yellow generation there actually doesn't change over time. Then we've got hydro. Hydro is green, great. It's also super flexible, which means if they need more electricity, they can turn the taps on at the dam, and suddenly you can generate a lot more electricity. But it's a limited resource. If you just left the taps on all day, the dam would be empty. Ecological impact. And also, you're probably using that water also to supply water to people in cities. So it's not something you can mess about with. It's something you need to use in a limited sort of way. The modern problem is wind and solar. The problem with those is when the sun shines and the wind blows, there's electricity. When they don't, there isn't. And those are pretty unpredictable things. So on this graph, you can see there, during the day, the brown area, during the day, about midday is the most solar power generated, and it falls off towards night. Yeah. The last thing here is the purple. And you can see the purple was used in the evening to deal with the hockey match. And this is something that the electricity companies have to now deal with. They need a smart grid, but basically they need to be able to store electricity to have the flexibility. Battery technology is not there yet. Hopefully it soon will be. And the Czech Republic has a very simple but very sophisticated solution. They have a reservoir at the top of a hill. And during the day, they pump water up to the top of the hill. And when they need a lot of electricity fast, they let it come back down again. And that solves that problem. This is how they balance out their inflexible nuclear power with maybe unexpected demand. So, and if you get it wrong, the Czech Republic are winning, the power goes out, then you're going to face some consequences. And what does it take to actually achieve that the lights don't go out? So 4 things: estimation and planning, proactivity, flexibility, and quality of supply. I'm going to leave quality of supply to one side. For the moment, I'm just going to talk about the first 3. So planning, proactivity, flexibility to ensure supply meets demand. So they do a lot of planning. They continuously plan. They plan months ahead, days ahead, during the day, 1 hour ahead. They're planning constantly and constantly adjusting those plans. And they've got lots of knowledge, they've got lots of tools, they've got lots of skills where they can keep refining that plan to make sure that their capacity to supply electricity is going to meet the demand. Then they're very proactive. They adjust their preparation. If they can see that possibly the demand is going to go up, they prepare. And also they do a lot of maintenance work to make sure the grid's in a good state to supply any electricity that might come along. And then also they're very flexible. So if the Czech Republic score an early goal or some part of the system breaks down, they have flexibility in the system to be able to respond to that problem. Let's switch to testing. This is the worst question in software testing. You're sitting there testing away, quite happy, and some guy comes along in a suit probably and says, "Hey, Phil," and you say, "Hi," and they say, "Phil, when will you finish testing?" And you go, when I'm asked that question, I get a piece of paper and I start drawing to try and explain the problem. And this is usually what I draw, something similar to this. And I say, in order to estimate the effort and duration of testing, I need to know all these things. And the stuff on the right-hand side is, for me, highly predictable. I'm a professional. I've got skills, I've got knowledge. I can define the test scope. I can define the types of testing I need to do. I can decide what sort of level of test intensity I need to do. From that, I know how many test cases I have. I can estimate how long they'll take me to write them, and I can estimate how long it'll take me to execute them. And the stuff on the left-hand side is what I can't predict because it's not in my control. And these are just some, there's probably some more, but just quickly, time pressure. If I'm under pressure, I'm probably going to be less effective. I'm actually going to be slower. Quality of test bases. I've written my test cases based on some test bases. When I start testing, I realize the system is doing something completely different. Where's the problem? Quality of development. How many defects will there be? Every defect, I have to write a defect report. And I have to retest it. It's extra work. Yeah? How many defects will we get? How much will they break when they write a new feature? These are things which worked before. Quality of test environment, quality of test data. How many times have you been stuck because the test environment was down unexpectedly, or you suddenly find you don't have the right test data? Quality of integration. You're doing end-to-end testing. If the downstream or upstream system is offline, then you're stuck. And human factors. Bob, the developer, is sick. COVID pandemic. These are things you just absolutely cannot predict are going to take place. So, but there's something we can do about this, in my opinion. So keeping the lights on. First of all, plan, replan. Every time you have any new information, just look at your plan and look at your estimates and revise them all the way through your process. And for those predictable things, just be a professional. Use good test analysis and test estimation techniques. They exist. Go read a book. And for the unpredictable side, again, be a professional. You're identifying risks and problems, and you need to communicate them. And you need to communicate them well, or no one will want to listen to you anymore. And even you can take a step further for those unpredictable things. You can do active mitigation. So avoid risks, solve problems, be proactive, support the left side quality improvement. So those things we saw on the left side of my picture, support trying to find solutions to those problems. And then you've also got passive mitigation, which is your flexibility. You can add contingency to your plan, of course, but be ready for damage limitation. Be ready for when the hits the fan. So let me just take proactivity and flexibility. Tester skills. What tester skills are required for proactivity and flexibility? In my opinion, and I'm singing this song a lot, soft skills. And in this day and age where we are focusing more and more on technical skills, my fear is that we'll forget the soft skills. And the soft skills are critical for us to be good software testers. Here is a list of soft skills. This is a keynote. I'm not going into details, but just look at that list and think about proactivity and flexibility. And you can see that those things will help you be more proactive and more flexible. And the hard skills, the quality of supply. Okay, is it hard skills? Or is it something else? So these are the buzzword technologies we're testing today. And the way we're testing them has changed because we've gone from waterfall, we're into DevOps. It's great, but it's a completely different approach and completely different way of testing than we had in NASA, for example. Yeah? Those things, we need to learn to be able to do these things. So that means hard skills. Well, yes, but also no, because everything's changing the whole time. So there's new technologies coming along, there's new ideas in testing, and you need to keep continuously learning new things. And how do you do that? Well, actually, to be able to do that, you need good soft skills. So again, soft skills, so hard skills, soft skills. We need a good balance. Final test. Electricity could help us avoid a global crisis. Now, I know what you're thinking, that I'm going to be dealing here with a climate crisis, and I'm not, because I couldn't. I actually tried to compare testing electricity, climate crisis, and testing, and I couldn't. So I'm going in my time machine, I'm cheating a little bit, I'm going back to the energy crisis. Before the climate crisis, there was an energy crisis, and it really was the same thing, just without the global warming. So we were worried about limited natural resources. We heard things like the coal is running out, the gas is running out. The earth cannot keep giving up and giving up because we'll run out soon. And we expected the demand, global demand for energy, to rise. The population is growing, it's slowing down, but it's still growing. And as the world hopefully develops and people get out of poverty, we can expect there'll be an increased demand for the Earth's resources. Power off. So the first thing we tried to do was conserve resources. So we install better light bulbs, we insulate our homes, and so forth and so on. So that's one approach to dealing with this problem. And in that, we also saw electricity had a great potential to help, because electricity is easy to generate from alternative resources, renewable resources. So like solar, wind, hydro, waves. Also, that's great because they're non-CO2 producing. So that was the other side, the solution. And obviously that creates big problems for the electricity industry. They've gone from their old hyper-flexible power, coal and gas power stations, and now, as we've already discussed, they're having to balance many different types of electricity sources which are not so flexible. So let's talk about growing demand, limited resources, intelligent and efficient use, and alternatives. A global software quality crisis. I'm not going to go into details. We are facing a workforce crisis. There are not enough people. Global demand for software testing will grow. There's more software. We have to test it more often. We could have a quality crisis. So we need to think about using our limited resources in a more intelligent way. We've already talked about that a little bit. Tools and technology can help us address the problem because they give us alternative sources of test automation, autonomous testing, all AI machine learning, all these ideas coming along can help give us an alternative way of approaching testing, for executing testing. But obviously all those things are creating us a problem, as I've explained. You need to have a lot more, you need to work on your skills to actually be able to supply those things. So how to prevent the crisis? Intelligent and efficient use. These are very, very old ideas. Let's start using them. So test when it's easy to fix, focus on grooming, use reviews, use risk-based testing. Yeah, so test the things which are important to test. And maybe because we're in a DevOps environment, those edge cases, we'll leave it to the users. They can find them better than us, and we can roll out a fix in an hour or two. The impact is very, very small. Test efficiently, use good techniques. Yeah, write good test cases, and renew, reuse, recycle. The number of times I've come across testing teams which are constantly writing new tests, I can't count. Yeah, you've got a bunch of tests there. Actually, it's a good idea to reuse them, because if you reuse them, you'll make them better and you'll start learning things as you go through it. Alternative sources. Here we have an autonomous tractor. We could use alternative resources too. Automate the low skill stuff. The tools are there to automate the boring, repetitive things. So start using them. I often see people struggling to automate the GUI. Why don't we test the API, which is behind the GUI, or maybe just start testing directly on the database? It's actually much easier to do test automation on services than it is on the GUI. Use good, as we talked about, good analysis and design techniques. Okay, let's use the techniques, but there are actually a few tools out there these days that can help you with that. And AI and machine learning, yeah, it's maybe being overpromised. We're talking about these days about autonomous testing, but there is some maturity in those tools already, and maybe we can actually start using them to help us in our job. And quality of supply. You need to continuously upskill and improve your knowledge to keep up, to actually do those two things. Conserve your resources and use alternatives. You need to continuously upskill and improve knowledge so you can make better choices and deal with the complexity, and so do a better job. So is testing like electricity? Mitigates risks? Yes. Is it dangerous? My opinion is yes. Makes modern life possible? I'd like to hope yes. Demand is unpredictable? Yes. And could it help avoid a global crisis? Testing can't help avoid a global crisis. Testers can avoid a global crisis by working on their skills. So, did I pass? I'd like to think yes. I'd like to hear your opinion afterwards. Do you pass? Now, your testing future. Let's take responsibility for our role in delivering business value. We're at the forefront of business these days. Let's invest in our skills to make the world a better place. Testing is shifting from low skill. It sounds hurtful to say it. We always thought it was a high skill job. Really, it wasn't. And now it's really becoming a high skill job. So we need to invest in our skills. And the good news is you're at TestCon. This is a 3-day conference. There's 4 tracks, 44 talks. There's experts from around the world who are here to share their experiences, their knowledge, and show you new skills and techniques. There are 800 other people on this conference who you can interact with and do the same. Share your skills and experience, and they will share theirs with them. Yeah, so that's the good news. Thank you for listening. I hope I've motivated you at least a little bit to face the challenges of the future. I'm social media shy. I am on LinkedIn. I'd be delighted if anyone reached out to connect or even start a conversation. So thank you very much.
Thank you, Phil, so much for this nice keynote. So actually, I feel quite stupid right now to not see the correlation beforehand. So thanks for that. I guess we can dive into a few questions. We only have one right now. So please, if you have any more questions, feel free to ask. So Thomas asked the question if the slide with the 4 generations of technology, if it's available as a PDF.
Yes.
Yes, I think we also uploaded the slides, right? So,
yeah.
All right.
Okay.
So
without the super exciting animations, unfortunately, but yes, it's there.
Well, yeah, you can reproduce them maybe, but I think the talk is also recorded, so you can recreate the animations if you want to. So, all right. So if we don't have any more questions, I have maybe one for you. So how did your colleagues come up with this topic? So I'm actually wondering.
Well, when we first started the company, there used to be an international testing conference in Prague. And we said, okay, this is our local conference. Somebody should go and speak there. So we were sitting around a table and there was complete silence. Nobody wanted to go and speak at the conference. And everyone said, but Phil, he's quite good at presenting. He should go there. And I said, and of course, I didn't want to say I didn't want to do it. I was saying, no, I've got no idea what I could talk about. So basically they said, okay, first idea was testing is like sex. And I said, no, I think that's not a good idea. Testing is like electricity. So basically I said, I wrote it down on a Post-it note and I went away, and it took me like 3 months to come up with even some ideas of how to do it. So it was quite hard, but hopefully it was interesting. And hopefully I showed you some inspiration from what they have to deal with and what we should be dealing with. And we can see some parallels in how to approach it.
Yeah, definitely. Interesting story. I really like it. So we have one more question. So in what way is testing most unlike electricity?
I think that's the first slide, isn't it? Where it's an energy created by charged particles. When I was first digging around, I said, okay, what's the definition of electricity and what's testing? Testing is electricity obviously is an energy. Yeah, and we maybe I would like to think that we create energy through testing, through enjoying testing and trying to be good software testers. but really it's a human process done by humans. I have to repeat this frequently, even though we're using tools. Tools are still set up, tests are still scripted and monitored and maintained by humans. It's still a highly human activity, and we need to interact with other humans to do the job well. So
yes,
yeah,
I see. All right, I hope this clarifies the question. So we have another one coming in. So what do you mean by hard skills for tests? So
hard skills these days, for me, hard skills is using tools, writing code. Even I always think that test analysis is a hard skill. It's an analysis, it's a hard skill. So in the old days, we thought we were being quite technical. We did test analysis, and maybe we were good enough to write SQL scripts to check the results in the database or create test data in the test database. So we were always fairly technical. But these days, the drive is that you need to learn to code. And it's not just learning syntax, it's you need to learn how to code. Yeah, Jonas, you're from a development background. It's really important to know a good coding approach to do good test automation. If you're using JavaScript or Python or, God forbid, Java for doing test automation, then it's syntax. And if you start with one syntax but use that syntax to learn to code and learn how to code well, and I do advise anybody just getting into test automation to really focus, try and find some course that teaches you how to code, preferably in JavaScript, because it's easy to understand even for an old guy like me. They're the hard skills we have to work on these days. So that's the primary focus for hard skills for testers these days, is learning how to code, learning syntax, how to use tools. And once you start using the tool, then you need to learn good test automation techniques. Otherwise, you'll just create yourself a lot of problems. Which we have a presentation tomorrow to talk about. So tune into that one. Test automation monsters.
Yeah, I'm really excited to see that as well. I cannot agree more. So I think also like hard skills, learning to code these days for testers really relevant. And I also liked one comment in the chat, which mentioned that actually you can, like with soft skills, you need soft skills to have like the hard skills or to deploy the hard skills correctly. So I think it's a nice combination of both what you need. All right. I guess there are no more questions then. So thank you all for your time.
Does that mean everybody understood or nobody understood anything? I
guess it's like they are all flashed, but it was really, really nice. Like a lot of information and perfect keynote fill. I can read through some comments and they seem all pretty amazed by your talk. Actually.
Okay. As I say, my job as a CEO is to motivate people, and I hope I've done something to motivate you. Yeah. Learning is fun. Yeah. The most exciting thing about learning is fun. When you get old like me and you're learning JavaScript and playing with Cypress or Playwright, it's great. It's fantastic. I love it. Yeah. So go for it. Yeah.
So we actually have one more question. So also, thank you very much. You told us a bit about traveling back in time, but where do you see software testing in the next, let's say, 10 years?
Okay. Different presentation, different conference. A few years ago, we were told testing is dead. Google said testing is dead. They had a conference back in 10 years ago, 12 years ago, where they had a talk, and it's a very, very good talk. It's on YouTube. I definitely suggest you go and find it. Testing is dead. Where they said that, testing is disappearing. We talk about it tomorrow in the Test Automation Monsters, why testing is disappearing. And I don't think so, because they're saying like AI and machine learning will be able to do the testing. And everybody, again, is underestimating what makes a good software tester. And that makes me angry. And I do believe that testing will be the last thing. If you take the Terminator films, we're the last humans fighting the machines. We have to stop the machines taking over. So if you talk about cognitive bias in AI machine learning, we're the guys who should be actually checking that sort of stuff and making sure that doesn't happen. So I believe testing has a really bright future. And some other areas of IT probably don't. And they're sort of laughing at us. And I think we'll be laughing at them in a few years' time.
Yeah, I again agree. Like I have to check out the talk for myself because I haven't seen it.
Yeah.
All right, so the session will end. So again, thank you all for joining. I hope you had a nice start in this conference. And thank you, Phil, again. And have fun like at the rest of the day.
Okay, enjoy the rest of the conference, everybody. I'll see you a couple of times as well. I'm on the panel today and I'm also presenting tomorrow. So looking forward to seeing you again.
All right. Bye, everyone.
Bye-bye.